I want to talk mainly about the development of science and technology and its consequences. Uh, I will make some economic statements, which, if I'm extremely lucky, will be as competent as Lester's astrophysical statements. We are a tool-using species. It's our only hedge against disaster. Our ancestors, when they came down from the trees 10 million years ago or something like that, were not faster than the competition, not stronger than the competition, not better camouflage, not better diggers or swimmers or flyers or runners. All we had going for us was being smarter, having hands with which we could build things. And that was and has been the secret of our success. We were technological from the beginning. So 2 million years ago, our ancestors had a vast stone and wood technology. We knew how to chip and flake and carve, and that's how we managed to make a living, and a very good living it was. That hunter-gatherer way of life spread to all 6 continents, existed for 1 million years, and the bulk of the evidence is that most of those economies had surpluses, and that the amount of time that people work in hunter-gatherer societies, even the paltry remnants that are around today, is less than the fraction of time that people work in modern industrial economies. So immediately there is a real question about how much progress has been made in the last 1 million years. The critical step in human history before the present time is the domestication of plants and animals, the agricultural revolution of roughly 10,000 years ago, where it was figured out that you could, instead of simply harvesting the vegetables and nuts and fruits that grew all by themselves, you could use, generally in river valleys, the natural irrigation and plant crops, and therefore produce a much larger food surplus than in a small area than was otherwise available. That meant that the previous way of life came to an abrupt halt. Previous way of life, the hunter-gatherers, was a nomadic style of existence. And if you're a nomad, you follow the game, you wander, you carry your possessions on your back along with your children, and that means you have extremely few possessions. Modern hunter-gatherer societies have no sense of personal property, no sense of ownership. The game is shot and it is distributed to lots of people. It's done as a matter of course among the can't say that exactly because you got to do that then simultaneously. Of the Republic of Botswana, the prey belongs not to the person who shot it, but the person who made the arrow. It's a very different kind of lifestyle, which it's very interesting, but I won't spend much time on it. But what I'd like to stress is that human beings have spent something like 99% of the history in an extremely different kind of social situation, extremely different kind of economic situation, but a very familiar kind of technological situation to what we have today. And to the extent that we have emotional predispositions that are hereditary, a lot of them must be geared to those hunter-gatherer times and find very little expression in modern industrial economies. Now, after the settled agricultural revolution, it was clear that you had to organize large numbers of people over large areas along the Nile or the Yangtze. This required a political organization that had never been seen before. It involved hierarchical political structures, which don't exist in any hunter-gatherer society on the planet. It involved enforcement, police, armies, which are extremely rare among hunter-gatherers. It involved slavery, which is unknown among hunter-gatherers. Uh, we are living in the last 10,000 years in an extremely anomalous circumstance for the history of the human species. Now, the technology has been monotonically developing, always for short-term advantage. It's extremely rare that a technological development is forsworn because 100 years from now we can see that there will be some serious negative consequences, even though 10 years from now we can see that there will be some significant advantage. We never think on those time scales. 100 years from now we'll be dead. Someone else's watch. Let them look out for that. Well, this passion for the short term over the long term, coupled with extraordinary technological prowess, has, I maintain, produced an extremely dangerous and critical circumstance at the present time. The technology now permits us to affect the entire planet. And so, apart from the evident economic interdependence of the planet, which Lester so brilliantly discussed just a moment ago, there is an enormous technological interdependence, and I'd like to give a few examples. The innocent act of burning fossil fuels, coal, peat, wood, natural gas, petroleum products, has consequences. It seems the most natural thing in the world. The global economy is geared mainly on the fossil fuels. But every time you burn a lump of coal, let's say, you combine the carbon in it with the oxygen in the air. That's where the energy comes from, and you produce carbon dioxide, CO2. Now let's just spend a moment on carbon dioxide. The air in this room has 0.03% carbon dioxide in it. It's a minor constituent. It's odorless. It's colorless. It's not poisonous, and it's transparent. Right here we are seeing each other. It must be transparent. It's transparent in the visible part of the spectrum, the ordinary kind of light that our eyes are sensitive to. But in the infrared part of the spectrum, the light beyond the red, it is not fully transparent. And at a wavelength like 15 microns, it's opaque. If our eyes were good at 15 microns, we could not see our finger in front of our face, which is why our eyes are not good at 15 microns, because that would be perfectly useless. Now, what determines the temperature of the Earth? Visible light comes from the sun, hits the surface of the Earth. Some of it's reflected back to space. The rest of it is absorbed by the ground. That goes into heating the Earth. And what we have is a kind of equilibrium. The Earth radiates to space just the same amount as what it absorbs from space, and that equilibrium determines the temperature of the Earth. But that is only part of the story. The other part has to do with the greenhouse effect, so-called, because of an imagined analogy to a florist's greenhouse. But the basic idea is that transparent atmosphere lets the sunlight in, but when the surface tries to radiate away into space in the infrared, that radiation is impeded by the partially opaque atmosphere in the infrared. Carbon dioxide is one of the causes, water vapor is another, ozone, chlorofluorocarbons. There's a number of molecules that are greenhouse gases and hold the heat in. Now, the lifetime of carbon dioxide molecules in the atmosphere is measured in thousands of years. So
every carbon dioxide molecule we put in the atmosphere will stay there for the foreseeable future and increases the greenhouse effect and therefore increases the temperature of the Earth globally, the worldwide temperature. The curve of carbon dioxide as a function of time is a kind of increasing sawtooth like that. The up-down is a seasonal cycle of vegetation on the planet. And the amount of carbon dioxide is monotonically increasing and has been doing that for many decades, in fact, possibly since the beginning of the Industrial Revolution. It is now entirely clear that the Earth's temperature is increasing as well, globally. At estimated rates of industrial and domestic use of fossil fuels, you can make some predictions. And there's, of course, some uncertainty, but a typical prediction is that at the projected rates of fossil fuel use, by the middle to late 21st century, that is roughly a century from now, the global temperature will have increased sufficiently to make massive climatic change on the planet. A typical prognostication is the conversion of the Ukraine and the American Midwest into something little different from scrub deserts. That will have significant economic consequences. But on a time scale that nobody worries about, because it's not our watch. It's our children and grandchildren. Let them worry about it. On the longer term, there's an even larger catastrophe in store, and that is the collapse of the West Antarctic ice sheet falling into the Antarctic Ocean, raising sea level by tens of meters all over the planet, and that means inundating every coastal city on Earth. And that's a much less certain prediction, the timescale. It's a little like what Lester was saying about economic forecasting. That it's going to happen is reasonably clear. When it's going to happen is less clear for something like 150 years from now. Now, maybe before then we will have figured out alternative energy sources. But because the time scale is so long for scavenging carbon dioxide out of the atmosphere, what we do is fundamentally irreversible now. So this raises an important question. What are our responsibilities to 2, 3, and 4 generations from now? Bearing in mind that it is extremely unlikely that there will be a technical fix to this problem then. Notice that carbon dioxide does not respect national boundaries, has never heard of national sovereignty, and therefore the burning of coal in the United States affects the climate in the Soviet Union and vice versa. Suppose that we were smart and started limiting the use of fossil fuels, made massive investments in alternative energy sources, solar power, and ultimately fusion power, thermonuclear reactions. What would the consequences be? Well, suppose the United States and the Soviet Union in 30 years, not out of the question, had economically viable fusion reactors and replaced their entire fossil fuel economies, despite enormous resistance from fossil fuel corporations. And would then everything be fine? Everything would not be fine. The third largest coal producer on the planet is China. China is in the throes of massive industrialization. Can we imagine the United States and the Soviet Union going to China and saying, look, we know we made some mistakes in our industrialization using fossil fuels, but please learn from our mistake. Don't you use coal as well, otherwise our farmers in the Ukraine and the Midwest are going to be in trouble. What's in it for China? I think the United States and the Soviet Union would have to provide the alternative power technology at a rate which was competitive with Chinese use of coal, which will be very cheap, in order to make much of a dent in Chinese thinking. Possibly China will be much more altruistic and planet-oriented than the United States and the Soviet Union, but I wonder if we can bet on that.